Hi guys, so my name's Byron. I run the Western Europe Business Division for Spotinst, and you're probably asking why is a business person running a technical session. Well, this session is about heroing Kubernetes in your businesses. So we probably all, most of us understand what Kubernetes is, but we'll touch a little on that. But it's also about how do we leverage that Kubernetes infrastructure that you've got, how do we make it easier to run? And how do we then hero that in your organization so that more of your business units, departments, DevOps teams consume that and consume it in a standardized way? So we were going to go through some demoing, but we've had some visual issues. So I'm going to try elongate some of these slides and talk a bit more, and we'll have a Q&A at the end. Most of you will probably understand what Kubernetes is, but I want to talk about the value and some of the components, and then how do we then take that infrastructure, take Kubernetes as a whole, and hero that within your organizations, and what that looks like and what the options are available for you. But before we start, I'm going to do a quick... I'm clicking on my laptop and it's not moving, so let's try that again. Before we start, I want to talk about what Spotinst is. So Spotinst was founded initially to run production workloads with the same SLA as you get from your on-demand and reserve instances. Okay? Now, for those of you that aren't aware, when you're building your data centers, when you were first looking at your private clouds, and you built your data centers, you didn't build them for the size that they currently are, you built them for what they would be in 3 to 5 years. Okay? And the cloud computing companies do exactly the same thing, especially now that your workloads are so elastic. Okay, so as you scale, other organizations may be downscaling, and to supplement that, they have this excess capacity. Unfortunately, it comes with no SLA. Okay, you get a 2-minute warning and it disappears. Now, I was originally going to create this as a workshop, but we only had 30 minutes. But I left this here. Let's click the right one. I left this here. So that we'll share this out to you. So if you do want to follow this workshop, I'm sure some of you are very advanced from a Kubernetes perspective, but some others maybe just teaching on it, just starting to use it. Then you can go to the link there, and it actually will take you through pretty much the process of what I'm going to go through today. So what's the value of Kubernetes? Okay, why do we use it? If you think about from your agile working methods, your DevOps regimes, then Kubernetes kind of fulfills that because it allows you to automate your deployments without any downtime effectively. It allows you to be quicker and more effective. And if we look at what Kubernetes is we all know it's an open source container management. The containers holding all the dependencies that you need to run the software across any different type of infrastructure. But Kubernetes allows you to run that at scale. Okay, allow different teams to access it and gives you that management layer to actually integrate your APIs and integrate into what you're running. Let's look at a quick history. So Borg, for those that aren't aware, was initially created by Google back in 2004. It was their cluster management tool for their new search engine. Okay? It wasn't until 10 years later that Kubernetes got originally released. And then they joined the Cloud Native Foundation, and back in 2015, along with Microsoft, Red Hat, and IBM, contributed to the community. So that's 4 years ago. We're pretty much at the point now that Kubernetes is being used mainstream. We've already heard a lot of the talks today. But let's move. Why Kubernetes? What are the real benefits to it? Okay, we can look at the portability, scalability. So how do we react? If you think about, even from a consumer perspective, Black Friday, when new tickets get released to football games, rugby, etc., you have this scalability and the reaction or predictability of how much you do need to scale. And Kubernetes and containers deliver this capability. I'm going to quickly go through, like I said, we were going to demonstrate a lot of this, but unfortunately we couldn't get it on, so I've inserted some backup slides. So we're going to go through the control plane really quickly. Firstly, we're going to look at that Kube API server. So everything that we do with inside our Kubernetes controller comes through the Kubernetes API. So anything from your kubectl or any components talking through the masters from the nodes all go via the API server. We move to the controller manager, and the controller manager runs multiple controllers, whether they're deployments, whether they're services, and effectively they run a control loop So anything that needs to be done, so you see your current state and the desired state, the controllers make sure that, that's achieved, okay? We then move down to etcd, where all our key values are stored. So from your services, your discovery, everything's stored in etcd. And then finally, we'll move down to our kube scheduler, which enables us to queue our pods and get them scheduled on to those different nodes. Let's look at that data plane. You've got two main components running on there. You've got an agent, which is your kubelet, which acts as the conduit between your masters and your kube API server. And then you've got your kube proxy, which effectively allows you to, let's click the button, that allows you to traverse and route all your IP translations. Let's just quickly look at some of those Kubernetes objects. So you've got deployments, you've got services, you've got replica sets, you've got pods, and you've got all your specs inside of them. And let's just click on some of these. And I'm going through these very quickly because I'm sure most of you are already aware of these. But if we think about a namespace is there to allow you to create almost a virtual cluster. So you can, I've seen organizations create separate namespaces for monitoring, separate namespaces for certain projects, or certain deployments. Your pod being your smallest component, which obviously keeps your container inside. And then you've got different labels and persistent volumes associated with that. Now, if we move forward to our daemon sets run, this is where you will get your monitoring and login on each of your nodes, okay? So it looks at what's happening across your pods, and you can configure them to get all the information with regards to and export them out. Lastly, looking at your deployments and your replica sets, this is where your controllers will actually handle your updates for your pods. So if you want a new deployment, your deployment controller will go through and update your pods, whether you've increased the amount of them, whether you've changed the image, et cetera, and it deploys this. It can do it in batch processes, and it can do it in rolling updates. And then we move to our services, which is all about how do we expose them out to our cloud? How do we expose them out to our users? You can schedule these out across different pods. You can use node ports. You can express it across the cluster IP, et cetera. Inside the Kubernetes, you've got your DNS. Typically, it's offered by Core DNS. You can change it. Here we are. And internally, you've got your default DNS records that allow you to get them to your service.namespace, svc.cluster.local. As I said, if you were on a workshop right now, we'll be able to go through all this and actually test it. We'll do it very quickly. It's all automated for you. And how do you interact with your Kubernetes cluster? So people call it different things, but kubectl. And this is where you can deploy and update your applications and services. So a very, very quick background on Kubernetes. I want it to be quick because I'm sure most of you are using this already. So we have Kubernetes, but what options do we have in terms of managing those Kubernetes infrastructures? So from Azure, from EKS, Google, GKE, Rancher, Kubernetes, Mesosphere, NetApp Kubernetes Service, OpenShift. There's lots of different ones. I'm sure you may even be using your own. You've got COPS in the background and loads of different services. So great success. Let's just get on with it. But really, what other options do we have? What are the problems actually in managing Kubernetes infrastructures? So if we think about when you're deploying your infrastructure and deploying your applications, actually managing that underlying infrastructure isn't something that you want to spend time on. So there are options around your managed services like your EKS, and you can go as high as Fargate if you want to use ECS and move a bit away from Kubernetes. But if you're managing it yourself, these are the types of things you're going to talk about. Resource allocations, how do I get high availability, so availability zones? How do I do volume affinities? What type of instances should I consume? All the kind of things that really, as part of moving to public cloud, you don't really want to do. But at the same time, if you let somebody else manage it for you, it normally has a cost deficit towards it. So this leaves you to lots of planning and more planning and more planning. So let's start we'll start very quickly and simply. We've got a worker node on each availability zone, and we're going to deploy a pod, different sizes, and they're going to go left and right. We're pretty happy. That's nice and easy. We're going to deploy some new pods. Everything's fine. But now I've got a new pod, and I don't have any resources available to it. So we're going to spin up a new node, and we can have a beer. Awesome. Now I've got a specification where actually I've got a pod that needs to reside in zone B. So we've put a specification there. We wait, and a node spun up. Now at this point, on the left-hand side, you've got a worker node that's only got one small pod running, and a worker node in the zone B, only having a small pod running. It's not exactly the most efficient. We're typically looking when we're looking at this from a cloud computing perspective in your different cloud providers, they look at it at an aggregate level. So you're wasting a lot of your resources. We put another pod in there, but now we've got a new pod that needs to be deployed, but we're looking at a persistent volume, and it needs to come from EUS 1A. But I've actually got resources available in 1B, but actually I didn't put any volume affinities in there. So actually, that means that it's inefficient. It's not good. Okay? Actually, what I should have done is spun up a worker node in 1A and actually connected that persistent volume. Great, we can have another beer. I think it's meant to be beer. Now, I'm looking at GPU. So I spin up another worker node meeting these GPUs. And these are all different. You can create different worker node groups actually to meet these requirements, all based on your labels and specifications. But now I've got all this unused space. So what do I do with it? Well, this is where you can move to a managed service. So you can use the likes of Fargate, Azure Container Services, Google Cloud Run. I'm sure we're mostly AWS here. But there are some pros and there are some cons to that. Typically, as you move up the stack in terms of who's managing what, you're paying more for the premium. But it does have these benefits. It removes a lot of the need to maintain underlying infrastructure because you don't really want to be managing infrastructure. You moved away from VMware or OpenStack to actually allow you to use serverless or containers and everything else because you want to concentrate on your deployments, not on managing that underlying infrastructure. But the advantages are they do support your different applications, both stateful and stateless, which is good. And they're dynamic. You don't have to worry about it. The downsides of it, because you're not managing it, because you can concentrate on which will make you more efficient in terms of deploying your services, be more reactive to the market trends, you're typically paying a premium for that. Downside, additionally, is you may not necessarily get access to all the logs, maintenance, and everything that you need to from those environments either, because it's not necessarily in your control. It's buying a managed service. So how do we take you from running Kubernetes quite successfully to becoming a Kubernetes hero, or heroing Kubernetes in your environments? And this is a two-folded question. One, it's about how do we take the work off you so you don't have to manage infrastructure? And secondly, how do we give visibility back to the business so you get buy-in from the business to allow you to carry on creating new services and be more agile? So this is Spotin's Ocean. So Spotin's created a platform, again, on Spot instances that actually creates the same serverless experience that you'd get from AWS Fargate that allows you to run your Kubernetes infrastructure on Spot. Does also do some other services, but we'll ignore that. It effectively abstracts your infrastructure, allows you to run what your DevOps teams want to do. It allows them to create their deployments, their services, their replica sets, and daemon sets, and everything else that they need to do. And it will create the desired state from what your requirements are. Okay? So how does it do it? It looks at the specifications and it builds the different instance types. It has a whole different RAID of different instance types. It may have them all. Okay? And you can create different worker groups. So if you have some GPU-specific ones or you have some persistent volumes, you can create different worker node groups that have those labels so they get spun up to meet the requirements that you put in your specification. Most importantly, it's actually done on a per pod level, on a per deployment level, not on an aggregate level. So you get rid of a lot of the inefficiencies. And I actually would demonstrate all this for you, but unfortunately we can't. Finally, Spot is good, but it does get removed. So you may have certain services that aren't allowed any interruption at all. Maybe you're not allowed in those particular pods to be restarted or created again. So you can put them on reserve instances, all within the same console. You can access it through Terraform, CloudFormation, so all it fits into your IAC. But additionally, you can also get visibility both in terms of cost, expansion, health, etc., through the console. So it gives you the operational components as much as it does the implementation. So it allows you to run cheap, reliable clusters, gives you auto scaling, Headroom, which is important, because if you've got very elastic workloads, then actually you don't want to be reactive. Sometimes you need to have that space in already. How do you really want to wait for an additional 10 instances to start? And in some cases, you may have a lot of work that needs to be done on those instances that actually takes time to boot them up. So let's actually create some Headroom. Now, on on-demand or reserve instances, Headroom could be quite costly, but at 80% off your pricing on demand, Headroom doesn't cost you a lot, so you can actually have quite a bit of Headroom. And lastly, we talk about right-sizing. when you enable auto-scaling, both from a cluster perspective, but also from a pod perspective, so looking at your requirements from a CPU or metrics or custom metrics, then we also need to be aware of what happens if we undersize or oversize our pods. Now, as developers or even infrastructure architects, we're notoriously bad at knowing what requirements are for our applications. So we always oversize. It's just a given, okay? Because the premise of undersizing means performance degradation, bad impact to the user convenience and experience. So if we go back to what we were looking at originally, where we've got these worker nodes with unused capacity, what actually we'll do is move the pods, because we understand what the individual requirements are for those pods, and put them on to access the availability within inside that cluster already. And then we'll move the rest of the worker nodes onto Spot. So you keep the same availability, and we'll always spin up a new instance before one's going to be spun down. Typically, it's done, we're aware about 15 minutes to 30 minutes before an instance is about to disappear. We're managing about 4 billion instance hours every month at the moment. So this is where we would go through the console and talk about it, but I'm going to finish back onto the pod right-sizing. So we have the capability to, because we're monitoring and looking after your infrastructure, we also understand what your pod's requirements are, what they're using. So we can give you recommendations, and you can actually store them as an array back into your deployments, so they constantly always have the right requirements, delivering you the best experience and getting rid of your idle resources, but also making sure you have the best performance. I would have finished with a demonstration just telling you that this allows you both from a technical perspective to deliver the best experience to your teams, but also from a business and operational perspective to actually give visibility back in from a cost perspective. So maybe seeing it on a namespace. Maybe you're sharing your Kubernetes clusters across different business units. So you can actually then at least have show back, if not charge back, for those resources as well. And that's it. Thank you for your time. Any questions? Hey. So we're actually integrated directly. We have a daemon set running within your... So how are we monitoring and monitoring the health of the cluster, but also the pods and everything within inside that? We actually run a daemon within inside your Kubernetes clusters that actually takes all that information. We're actually looking at both what pending pods are running. We're actually speaking to the Kube API to find out what the health of each of those pods are, making recommendations. So you'll get visibility both through the console, but also alerting tools so you can look through the Grafana, or you can pass it out through any syslogging tools that you want to use as well. Any other questions? Well, thank you. I think I did all right for time.